This is an awesome start. Thank you, everyone, for coming. Quick introduction. My name is Jason. This is Atanas. We are engineers in the Edge engineering team, and I mean, I guess we could say we're the best engineers in that team. So you guys are in for a really good start. Yeah, there we go.
We are.
You know, I set the bar way too high to start with. Let's just tone it down a bit. So quite a few things to talk about today. Big audience, want to make sure we have time for questions. But this is the first in a series of Edge Talks you're going to be hearing over the course of the week. So I do want to spend a little time at the beginning, bringing everyone up to speed, making sure you have an idea of what the word Edge means, and also laying the groundwork for what you're going to see a little bit later on in the week. And then we'll obviously spend quite a bit of time talking about Edge Image Builder itself, and then we'll end with a demo. So to get started, you're going to see this slide or variations on this the rest of the week. There are 10 some odd sessions. A couple of presenters are floating around here. Keith Basil will be talking about Edge in the keynote tomorrow. So quite a bit. Oh, ready to see the picture coming in? All right, cool. So you'll see this content floating around. One of the reasons we're going to bring it up is to show where each of these individual talks fits into the overall Edge picture. Now, there's a lot going on in this. There's three main takeaways I want you to come away with this slide from. Number one, this is not our traditional data center, which means the ways of doing things that have worked in the past don't really work at the edge. And that has caused all sorts of complications and really interesting challenges for us. Come on in, you're good. Number two, I want you to pay attention. As we go further out, that scale jumps significantly. I don't need to explain to this crowd that scale presents a problem, but in our case, when we're looking at the 10,000, 20,000, 35,000 nodes, suddenly management, maintainability, day two, all becomes a much bigger story and a much more difficult story to answer. And the third point is, the further we get out, pay attention to the resource constraints that start to exist. Our hardware gets significantly less powerful. Our network gets significantly more complicated. Potentially low bandwidth situations, systems that are only checking in periodically and don't quite have that nice data center constant connection where you're sitting right next to the media server on a gigabit switch. We're talking about situations where, since you are so far outside of the data center, the network and how you do all the management of the systems becomes a lot trickier. And again, this slide and the next one, you'll see a couple of times over the course of the week. I want you to focus on the two areas in green for the purpose of this talk. The idea of zero-touch provisioning. How do we make it so that you are not sitting there for 10, 20, 50,000 machines, manually configuring each of them and building an image and saying these pieces are going in the right spot? We're also talking about environments where you may not have Bob from IT who really understands hands-on at the machine, this is how I do things. If we're talking about retail, they probably don't have an IT department that is really going to want to get into the difficulties of setting up all of the infrastructure, setting up all the dependencies, keeping it running. So the idea of zero touch, how do we make it so that on a retail site, they plug in the machine, and from a centralized location, we do everything it is they need to know. And the other part here, this additional network constraints, I touched a bit on in the last slide, the idea of low bandwidth, but it goes even further than that. From the get-go, we have had to deal with air gap situations. And as I say that, I worry Atanas is going to go into the corner and cry because that has been a very, very tricky part for us. But that is a very real concern, that we have to deal with these situations of it is a fully air gap situation. And how do you handle not just getting the machine initially provisioned, but getting workloads on it? Last of the slides that you're going to see multiple times, what does zero-touch provisioning mean? And over the course of the week, the variety of Edge talks are going to help really paint this picture. And to go from left to right, the idea of directed network provisioning. So I have a list of hardware that I purchased and I know about. I want to hand it to something and have it go and provision and make sure all of the machines are configured and running the workloads I want. Not exactly sustainable to say, I'll have an intern run around and install them all. So I want to do this from a central location, from literal bare metal powered off all the way up to running and serving workloads. Phone home provisioning, the exact opposite. I don't know the hardware. I simply know, hey, here is an image that can connect back to my enterprise and say, I am now part of the enterprise, manage me, configure me, and so forth. Similarly, we need to have an image in place that has that information. We need to be able to provide it to the manufacturers and say, burn this onto the device so that way, when it actually boots up, it's going to connect home to my system. And I'm going to do that for most of the pictures, just going to warn you guys now. I lost my train of thought. Phone home. So how do I call back and say, look, I am now new hardware that should be managed by you, get me set up. And then the third piece where Edge Image Builder really starts to come into play, and it is applicable in the first two as well, but I want this image that has everything I'm going to need to run on it, not just my operating system for, I've taken SLE Micro, downloaded it, and shoved it onto a USB key. I need all of the workloads, I need all the configuration. I want an HA Kubernetes cluster. I want complex network configurations that it's going to span multiple nodes. So these are A, just a fraction of the questions that we're answering over in the Edge engineering team, but B, these are the relevant pieces for Edge Image Builder. And with that, I'm going to hand it over to Atanas to actually tell you what it is.
So, what is it? Jason made many great points about what we need to solve at the Edge, and when it comes to Edge Image Builder, it is just a standalone tool which is able to answer most of the needs that we already talked about. So, you take an image, you modify it, you build it, you customize it, and then the result you can use for any Edge environment that you are having. So we support several different operating system formats, namely self-install ISOs and raw images. Now, when it comes to Edge, we all know about minimal resources, lots of constraints, and very, very different edge cases, pun intended. In this way, we will be using only SLE Micro for that, just because any other Linux distribution may be too heavy for our use cases and configurations. Now, for those of you who are not familiar with combustion, this is something that we heavily rely on in order to customize our base operating system, and this is a tool developed and maintained by SUSE employees, which is used to configure the operating system during its first boot. It's a very simple system unit which provides a set of scripts running at different points before the actual provisioning process. Last but not least, a very bold statement here that we have in green. When we talk about Edge Image Builder, we obviously are able to solve problems with a single image for standalone clusters, standalone environments, standalone nodes. However, its main strength is within the option to create and build a single image and use that very same image across multiple different deployments. Jason many times mentioned about the challenges of scale and the challenges of having someone go to your Edge environment, do something about your Edge image, about your Edge node, and have it actually run. Well, what happens if you have 5 nodes? It's doable. What happens if you have 50 or 500? It's not so easy. Now, when it comes to one image multiple deployments, this obviously means complex networking configurations as well as high availability Kubernetes clusters. We are not aiming to provide any sort of small sample configuration. We want to be able to create a fully fledged cluster which is able to deploy all of its user workloads in an air-gapped way. So to continue, obviously, if you want to configure many different things at once, this has the implication of having many different dependencies on your host machine. Well, this might be tricky just because you might start running into versioning issues, you might start running into dependencies missing on specific setups. So this is why EIB is created and distributed as a container image, just so that you can pull it from any container registry and just run it, either with Podman, Docker, or any other container runtime. Now, Edge Image Builder is a fairly new project. It was started in October last year. We managed to create and release a GA version just last month. And this had the implications of having not be fully fledged and complete. At this moment, it runs on x86 architectures and it is able to customize and build x86 images. Now, this is a limitation that we are very aware of, and of course with the huge increase in popularity in ARM architecture devices, we're currently aiming and working on introducing the ARM support for EIB both on the host level as well as on the building images level. So you'll be able to run EIB on ARM, you'll be able to build ARM images with it. This is coming very soon. Now, obviously, is all of the spirit in SUSE. This is open source. Down below is the link to the GitHub repository. You can see the whole process of developing, debugging, raising issues, finding problems, investigating those, resolving those, and in total, the very evolution of this project over the last couple of months. Now, if anyone is wondering about its implementation details, what it is written in, well, we can just say that it is the unholy child of Golang and some bash scripts, just because bash is the native combustion way of doing things, and Go is obviously one of the most popular languages in the landscape of open source and container technologies. Now, with any software tool, if you want to have a meaningful result, meaningful output, then you have to have a meaningful input. So in the very middle of this slide, of this diagram, you'll see EIB. To the right is the image which we call CRB, or customized ready to boot. This is the image that we're able to just grab, stick it on a USB key, use it for a virtual machine, use it wherever you want to provision our final edge environment. However, how do we get to it? Well, there are three different components. We'll list them briefly here, and we'll talk about them in the next slides. So we have the image definition file, we have a configuration directory storing various files, and then finally, last but not least, we have the base SLE Micro image. This is the operating system image which you, most of you download from the official SUSE customer center, which we then go through the process of customizing until we arrive at the destination. Now, to briefly touch on the first two, the image definition file is something which we use as a schema for our configuration. It contains most of the different configuration options that we want to modify, as well as most of the critical components that form a multi-node Kubernetes cluster. It will list all sorts of different settings. It will list operating system settings, it will list Kubernetes ones. It might list some sort of RPM packages, but more on that later. Now, the configuration files directory is almost optional. We'll dive into where it might be necessary, but it is there to serve as something to slightly improve the way that we handle the modification without necessarily having to list everything into the image definition file. The image definition file, in the end, it's just a single YAML file with, again, a predefined schema that will be populating from here on. Now, what are the capabilities? What is Edge Image Builder capable of doing? We'll start with the base operating system things. Well, obviously, all of you know that once you provision your operating system, you might have to configure users and the groups that they're part of. You might have to configure time settings, kernel arguments during the provisioning itself, as well as system units, and so on and so forth. This list is non-exhaustive. There are a lot of different features that we are able to modify on the base operating system. Again, we're talking about scale here. You might be fine with configuring the users and groups on a single or 10 node setup. However, what happens when you have 50 nodes? Well, then it is kind of heavy on Bob from IT. Next one, RPM downloading and installation. You obviously know that a lot of the user workloads will not just work straight out of the box. You might have some dependencies to install, and very often these dependencies might be coming from RPMs. Now, when it comes to RPMs, we have the opportunity to specify those and install those in very different scenarios. So you're able to just list them using their names and the SUSE registration code, which is able to fetch them from the official repository. You could obviously use third-party repositories. You could as well as, if using private repositories, just download these RPM files and provide them manually using the configuration files directory that we briefly mentioned in the previous section. Now, the most important thing here, and highlighted in green, is that, well, we have the dependency resolution to think about. What happens if we just list an RPM, we build the image, we ship it to a edge destination, we provision it, and it fails at boot? Well, obviously we have failed. However, the package dependency resolution feature of EIB will make sure that if the dependency of any RPM which is listed is not installed, then we'll be failing on the image building process, ensuring that every time we build an image, it is able to just be provisioned without any failures whatsoever. Again, many different ways to specify an RPM and a lot of different options for the end user. This solves our air-gapped solution scenario for RPM installations without any sorts of issues by pre-downloading, pre-trying to install those RPMs, and then shipping those over the last fully built image. Now, when it comes to any sort of data operations, again, security, upgrades, all of those things that you think about when you hear about data, you have maybe the idea of having this remote control procedure, or phone home rather, for Elemental. But this is one of these cases which Jason previously touched on the slide about the different edge use cases. So Edge Image Builder, aside from anything else, will allow you to either will also allow you to either, if you want to specify it, register via Elemental or SUSE Manager, just to make sure that your final node is able to be upgraded without any sort of issues from the remote environment. Oh, networking, this is an interesting one. Well, this is something that makes or breaks the solution. Pretty much. SLE Micro is using Network Manager under the hood to modify the different network configurations. And while this is something that is very tricky to work with, we may have come up with a solution satisfying a lot of different use cases. Again, going back to the first slide of what Edge Image Builder is, we talked about having a single image which is able and capable of deploying multiple different nodes. However, those different nodes, and obviously when they're different parts of the Kubernetes cluster, regardless of whether they're servers or agents, they'll have different configurations, especially networking ones. So when it comes to this, we have developed an edge-specific custom configurator, which relies on the wildly popular NM state schema to generate the network configurations for all the nodes that we want to provision beforehand, list them in the definition, and then have the final image, when provisioned, understand that, well, this is the node that I'm working on. These are the configurations that I need. So I'll apply those and have those specific, unique configurations. Now, more on that, how it is working, can be a whole separate topic, but the main process is that we're using MAC address matching under the hood in order to understand exactly which machine we are running on. However, aside from that, we also provide different options to the user in case they are not satisfied by this. They might want to bring their own provided script for their networking configuration. In any case, if anything fails in the first place, we will always default to DHCP, just because this is a valid way of loading hostname, networking configuration, and so on and so forth. So again, as anything else so far, we give a lot of freedom to the user, a lot of different options, and they're able to use the case that they see fit for the cases that they want. Kubernetes. Well, when it comes to Kubernetes, we obviously support the distributions that SUSE and Rancher are creating, updating, and supporting, namely RK2 and K-Trace. Again, highlighted in green, one image for the entire cluster, we are able to define all the different nodes that the image will be provisioned on. In the definition file, we are able to tell them which will be server, which will be agent, which will be the initializer node for the cluster. And we will be pre-downloading all the different Kubernetes artifacts, mainly ktrace binary or RK2 tarbos, and all sorts of other dependencies, for example, different CNIs, in order for us to have the different options in a completely air-gapped way again. We want to solve for air-gapped first, and this is how we do it. Now, obviously, we don't really care about a Kubernetes cluster if there is nothing on it to run. So we need to take into consideration what exactly we want to automate for the user. Now, this would be obviously the Kubernetes workloads, which we split into two different categories: the Kubernetes manifests as well as Helm charts. Now, Kubernetes manifests as well as any other sort of way to fetch those, regardless of whether it will be a local one or fetched from a URL, will contain, for example, a container image that we want to download, that we want to pre-download. This is again in order to solve for air-gapped first. So we'll be scanning all the manifests that the user provides. We'll be scanning all the different Helm charts for all the container images that those contain. We'll pre-download them, include them into the build image, and once provisioned, we'll be using a local registry, which will then be serving those images, again, without relying on an external network. Obviously, those Kubernetes manifests, if they don't reference anything, they would still be applied. Those Helm charts will still be installed to the final clusters. The Helm charts themselves will be also pre-downloaded and included into the build image. And last but not least, we realized that there will be a lot of custom hooks that the user might want to plug in into their own build and setup. So we provide the user the option to bring in any sort of custom files or custom scripts which they might want to execute on them, for themselves. This is because, again, every workload is different. Everything that the user might want to actually, the users themselves know what is the best about provisioning their edge environments. We'll just make sure that anything that they might want to include externally is allowed by us, in order for them to include any sort of private files, any sort of scripts that they don't want to be public, and so on and so forth. With that, I'm handing over the demonstration to Jason.
All right. So let me paint you a picture of what you're about to see. First and foremost, it's a pre-recorded demo. And the official stance is I may be devilishly handsome, but some of these things are long running and you do not want to stare at me while they run. The unofficial answer is I'm a coward and don't really like doing live demos. I've been burned enough. Yeah, a lot of thumbs up there. He gets it. You know, I say that, but Google Slides was very temperamental with me earlier, so if I have to restart videos, apologies now. So what are we going to see? Over the course of a couple of different mini videos, we're going to build up a single image. That image is going to be based off of SLE Micro. It's going to have simple root password in there so we can log into the machine. We're going to install a few RPMs. We're going to install a HA Kubernetes cluster and then deploy some workloads to it. Now, there's significantly more we can do with Image Builder. We are time constraint here, but I think that'll give you a good flavor of it and kind of get things going. I forget if I mentioned this part, so these are going to be running in 4 VMs on a machine just in my basement. Not technically air-gapped, but everything would have worked in air-gapped situation back from where we were testing. So to start with, Atanas introduced the idea of the image definition. Now, it is breathtakingly boring to show you a ton of YAML. So instead of one giant YAML file, I'm going to split it across 4, and it's still going to be equally as boring, but come with me on this because it's important. So the definition effectively defines a single image that we're going to be using. We've highlighted this a couple of times now, but I really want to stress that this one image can be used for multiple nodes. We will be building a single image that deploys a full-blown HA Kubernetes cluster with custom network configuration. That was very important to us. When we go back to the scale idea, we don't want to be burning 10,000 images and having to track that 8,153 belongs on this node or something like that. So this is the basics. Realistically, the operating system section isn't even needed. Just that top section that indicates the architecture that we're building. Thomas mentioned it before. Right now, we're currently x86 only, working very hard on the ARM support. It's actually Daniel over there working on it. He got his first gray hair doing it. I'm super proud of him. We're waiting to see as it starts falling out. It's not far behind. Image types. So for this demo, we're going to use an ISO, so I can demo the self-installing portion of the ISO. We could do ISO or raw images. And then we specify here the base SLE Micro that we're building on top of. This was just downloaded from SUSE like normal. And then the name of the ISO that I'm creating. Now those 5 lines are realistically the only thing I would need to build a new image. Not particularly interesting because it would just be SLE Micro all over again. So to start with, this ISO configuration is what's going to let us have the ISO installation run unattended. Those of you who have installed SLE Micro on your own through the ISO, the first thing it does is say, do you want to install? And then sits there and waits for you to press enter. That didn't work for us. We're going to have situations where, again, we're sending out a USB key to someone who's not an IT admin, and we're not going to want them to go through the juice installer, least of all, much less all of the process of selecting the disk and so forth. So with this set of configuration, you'll see it briefly in the demo. You simply boot into the ISO, and it takes care of everything after that and results in a running system. And the second piece here is my extremely secure password that I have chopped out the middle of, only because it's too much on the screen. Now, Atanas also mentioned the image configuration directory. This is the second piece that you need alongside your definition. At bare minimum, it's going to provide the SLE Micro base operating system we're building from. In this case, I have 2 custom scripts in there. SUSECon 24 is simply going to drop a very cheesy welcome to SUSECon message when you boot the node. And the root shell is because I've been using Linux for 20 years now and still impulsively type LL whenever I get to a terminal. That is not a default on SLE Micro and is driving me personally insane. So I include that on all of my images as well. I'm hearing laughter, so everyone else appreciates my pain with LL. So to build an image, might be a little hard to see. Thankfully, this room is kind of shallow, but I really don't even need you to read all of the details on here. I'll point out the important pieces. It's run as a container, as Atanas mentioned. So we have a podman command above. Amongst all of the ongoing text there, you'll see we mount the image configuration directory into the container. And then we specify which definition file we want to use. And that gives us a lot of benefits. We don't have a crazy install process. In fact, if I hadn't pulled the image ahead of time, it would have just simply downloaded it and run it right there, which is great because we do a lot of weird things under the covers to do all this image manipulation. So not having a ton of heavyweight, install this, use this operating system, and so forth, makes our lives significantly easier. So you can see, and again, I don't expect anybody to read this, but it's going through all of the different sections of things that can be configured. Almost all of these should be represented in what Atanas talked about earlier. Now you saw a progress bar up here. This was downloading, I was going to say this was downloading Kubernetes. I had actually pre-downloaded it and cached it because it's kind of large. What that is doing is setting up the artifact registry so that way on the node itself, when it boots, it can self-serve any container images and user workloads that is necessary. As the demo goes on, that'll become a little more obvious when we get to that piece of it. At the end, we build the image. And if I can catch it before the video restarts, I quickly output that we have the ISO created in the directory of the image. So it does come back outside the container. You don't have to do anything weird with that. A really long way of saying you simply create your configuration directory, you create your file, you pass it to a container, and out on the other end pops a brand new ISO that you can now distribute to all of your nodes and have run. Okay, let's build it out a little bit more. So the operating system pieces, the first 2 you saw already, and these can obviously be fleshed out. You can configure the many more users. You can configure SSH keys for the users, home directory, a lot of the typical things you would expect to see. The packages is much more interesting here. We want to tell it, hey, I want these RPMs to be installed on the node when it boots. In this case, wget2 comes from the default SLE Micro repositories. The Riser FS debug, it's one of those things that you end up using in a test like 6 months ago and nobody remembers why you picked that as the example, but it just kind of carried forward and here we are today. The important part is it comes from a separate repo that is not by default defined in SLE Micro. That's not the real URL. I wanted to fit it on the slide, but trust me on that. It points to an actual RPM repository. And then the SEC registration code, because I really do not want to get fired because a bunch of you start registering nodes in my name, I have blurred that out as well. I see some disappointed faces, which really scares me because like people are ready to take notes on that. Okay, two things I want to point out in this portion of the demo. Number one, at the top left here is the first node. Remember, we're ultimately going to stand up 4 nodes over the course of this demo. First one's already running. We're going to trigger the second one to start, only to show you that this install is what you would normally see and have to press enter. This is going to progress on its own. Again, if you are in a situation, and you will be in a situation with Edge, where you don't have an IT department and people particularly comfortable with Linux machines and configuring them, you give them this one ISO, they plug it into the box, and that's basically it. All of the rest of the things that we're showing will come along for the ride and get done on the first boot. Might be a little difficult to read, but it's also, to be honest, not the most interesting part of the demo. It is simply showing the RPM commands that show wget was installed and this riser fs was installed. You'll see it on this node 2 when it starts up as well. Now, the part I really want to hammer home is these RPMs are embedded inside of that ISO when and installed on first boot. That air gap situation I mentioned earlier that caused us all sorts of fun and headaches gives us the ability to not need an active connection to get all those RPMs. And Atanas mentioned it, but it's cool enough where I'm going to say it again. The dependency resolution is done by image builder. So wget, very simple example. We don't have a lot of dependencies. Let's say I chose something beefier that ended up tracking through dozens, if not more, RPMs. Edge Image Builder will detect that, download all of those RPMs, and pre-include them in the image. And then on first boot, the RPM runs. So you don't need to have this active internet connection. The STC registration code is not even included in the node. That is very intentional for security purposes. All of the RPMs and information we need are going to be built into it. So that way, as I distribute it to my edge sites, my low bandwidth sites, my satellites, I don't have to worry about being able to retrieve those RPMs at boot time. It's all packaged inside of it. Oh, we're good on time. Step 3, let's talk about networking. So there are 4 nodes, cleverly named nodes 1 through 4. The way the networking works in Image Builder is you define a network configuration file per node. That file, again, a lot of YAML. Again, don't particularly expect you to read it. Pay attention to the 2 areas in blue, though. One of the benefits of working with virtual machines is I have free reign over the MAC addresses. So AA is node 1, BB is node 2, and so on and so forth. I also have free reign over the IPs because this was just simply in my house. I'm going to get one of them is going to be good, and I want you to find me at the end of the event and send it to me. I have a collection, I'm not even kidding you, for years. COVID was very disappointing. I got no pictures of that. It sucked. IP address. So it was just simply on my network at home, so I had free reign of those. So node 1 is 201, node 2 is 202, and so forth. So back to our demo. We have our 2 nodes running. Now, the fact that the prompt includes hostname kind of buries the lead a little bit here. But you can see the host name is configured. We show the IP address. If you quickly note, you'll see the AA in the MAC address and the 201. As we go over to node 2, this is a very tricky thing to demo because what's happening under the covers is awesome. And I know me and Atanas are super excited seeing this. At the end of the day, you're like, yeah, you ran IP. Why did I come all the way to Berlin to see this? Trust me when I tell you, the actual mechanics that are going on are very important. Let's take a step back. That is a single node that I have, I'm sorry, a single image that I have used this one ISO to boot 2 different virtual machines. And as it booted, it detected using the MAC address, this is the network configuration that I should use for this machine, and then sets it, which is how we end up getting these 2 nodes that are not conflicting, that are honoring our current network configuration, and so on and so forth. All of that, again, is baked into the image, applied when it first boots. So let's keep going. Now we want to deploy Kubernetes. I keep saying now, this is ultimately all, again, one image. I'm just showing it in pieces because a wall of YAML is going to put literally everyone in this room to sleep, myself included. Once we get to the Kubernetes section, it really is as simple as simply saying the version we want to use. RK2 or K3S, we handle any of the differences under the covers and what the configuration takes. Here we're going to lay out our architecture. So we're going to have 3 servers and just a single agent running. We can obviously do more than that. Something not included in this demo is the ability to include your server and agent YAML files that get dropped directly onto the boxes themselves. So the fact that this is so lightweight, don't take that to mean rigid. You have all of the access to your configuration files you would for RK2 or K3S. They're just not directly embedded into the definition. They would be included as files directly in the configuration directory. Reminder of where we are, we have 2 nodes running. We have shown they both have the network configuration set. And we'll very quickly just use kubectl to get the nodes and show that the 2 nodes that we have created and are running are registered with Kubernetes. Now that happened already. That seems a little magical, so we're going to start nodes 3 and nodes 4. What they're going to do is start up, run through the same process. So it is going to install wget, it is going to install the riserfs debug. We jump through time a bit because VMs take time to start. One thing, I highly doubt this is readable, but I mentioned earlier that I have a custom script that drops the cheesy welcome to SUSECon message. If you squint, you can see that it is in fact present on the image as well. Right above that, just a marker saying Edge Image Builder created this image, so that way we have a way of understanding the version of Image Builder and the fact that it came from there. Ignore the git SHA. I'm cool in using a development version rather than a production one. This looks a lot nicer when you actually pay for the bits. So those 2 nodes have started. To prove they are part of the Kubernetes cluster, told you Google's messing me up here, just start it over again. But to prove that they have successfully joined the cluster, we'll go back and we'll run the kubectl get nodes, and we should now see, not exactly readable, but you saw 4 entries appear there. And if we dug a little bit deeper, and I had zoomed in a tiny bit more, you could have seen there were 3 servers and then the 1 agent node that we talked about in the configuration. Last piece, I really like how Atanas put this. Kubernetes is great and all, but without user workloads, the empty cluster problem really gets us nothing but a whole bunch of wasted resources. What we really need is the ability to include user workloads and embed those again in the image and have them start up alongside of it. Here we're going to use define a Helm chart that exists in an existing repository. I really hope that came through on the recording because this is going to freak anyone not watching it. So we define a repository we want to pull our charts from, and in this case, we're going to say we want to install MySQL. We're also going to include a manifest file. So again, this image configuration directory is the second way of getting input into Image Builder. I mentioned how the server and agent configs for Kubernetes go in here. I dropped my custom scripts that you saw earlier. I can drop custom manifests that are just your standard Kubernetes manifests that get deployed once the node joins the cluster. I could additionally have side-loaded some RPMs in here. So if I don't have a repository and I'm using a local policy file or something like that, you don't need to jump through hoops and get it into a repo and download. You can slide it into the image that way. Also, we saw earlier the network configuration files. Those are also included in this directory. So we should see 2 workloads get deployed. MySQL coming from a hosted Helm repository, and then Nginx deployed simply through Kubernetes manifests that were included in the image. I know I'm going to sound like a broken record saying this, but all of those workloads are pre-downloaded and included in the image. So that way, no network connection, let me change that, no public internet connection is necessary when these boot. Your air-gap situations or your government situations where you have to really vet what goes into the images, we don't have to worry about any of that because it's included in the image. Now, thankfully, this room is fairly shallow, so I think you can at least get the idea there that we're looking at MySQL running at the bottom there, and then a whole bunch of Nginx pods as well that were deployed. Again, it's a very hard thing to come up here and show off as, cool, this is really new and innovative. But you got to remember what's going on, that we literally did nothing but boot the virtual machines. I didn't cut anything out there where you saw me typing a whole bunch of things in. You saw me just press boot on those VMs. All of this was handled at first boot. I'm going to turn over to questions in a second. As Atana said, we are an open source project. Yeah, get this cameras out. Come on, I'm posting for this one. So we are an open source project. Any issues you find, which will be none because we are in fact excellent developers, you can file on the GitHub, or you can just file the issues, say hi to us. No, I'm kidding. You can go to, so we have quite a bit on here, trying to make this a normal open source project. We're SUSE, this is what we do here. So you can have access to the code, access to the issues, submit pull requests if you're so inclined. This link, there's a lot to type there, but you'll find it very easily from the homepage of the repository. That is a much more in-depth guide to creating images, well above what I showed you today. But all of those YAML snippets that I don't expect anyone to memorize, nor do I expect if you took a picture you to retype it, all of that's included in here with examples, so that way you can look through the sections and figure out what you want. In my environment, I know I need Kubernetes and a whole bunch of Helm charts. Just skim over the RPMs and so on, get to the meat of what you need. The point of the demo is to give you an idea of how ultimately little it is that you need to go into creating an image to get what you want out of it. And that guy's going to bring you through the rest of it. I'm going to turn over questions in a second. I'll leave this slide up instead of the thank you for those of you who still need to take a picture. I want to remind everyone that there are a number of Edge sessions over the course of this week. I know we are talking about the process we are using for validating these complex non-data center type scenarios. We have talks about the provisioning where you point it at a bare metal machine that's off and say go, and it starts it up, along with at least a half a dozen others that I'm unfortunately blanking on. I literally thought to include a slide here, and the list was too damn big. So just search for Edge in the session. Keep an ear out for Basil tomorrow. He's going to be talking about it in the keynote as well. With that, that's what we have. Do we have any questions? Do you mind? Please, for the recording purposes.
So this is awesome, but
good, thank you.
Yeah.
Next.
No. I've got a lot of customers with sort of, the air gapped requirement, cases of boats, factory lines, the kind of thing where you really can't get stuff out there. But also, this thing's going to be running for a long period of time. So they don't want to use like SLE Micro 5.5 vanilla. They want SLE Micro 5.5 with all of the maintenance updates that are available at the day they build the darn thing, because that's the image they want to use. What's your maintenance update story?
Yeah, I'm going to stop you at this was awesome, and we're going to ignore the rest of the question because that's difficult. No, question, actually, no, I started smiling because I actually have an answer to this one. Normally you ask for questions, you're like, oh crap. So the question was around SLE Micro. When I downloaded it, is older-ish. It doesn't necessarily have all of the newest packages, the maintenance updates. I'm waiting for Reese to start cracking up back there because this has been the bane of our existence for a couple of months now, and this has been a very specific problem we've had to solve. There's a couple of different answers. As of right now, customers can get access to OBS and use Kiwi to build the image themselves with the updated packages. Then they run that image through Image Builder for the customization. That's not a great answer. I appreciate the nodding along. We do have a better answer coming. On the roadmap, and that is the extent that I'm going to say, I'm not committing to any dates because someone in here is going to throw something at me. If it's Reese, if it's Thomas, whatever. We are looking at integrating Kiwi as well to make that as a part of Edge Image Builder. So you'll include the definition in the definition that says these are the updated packages I want. And then the first step will be, instead of download SLE Micro, it's going to be, EIB is going to integrate with the SUSE build system to create you that updated image with those newer pieces. Because exactly, there's a reason why this was the very first question that you very anxiously got up there to ask. Everyone's asking it, and it's a very, very valid question. And something that, Atanas mentioned, this project really started in October of last year. We GA'd in April, which is an incredibly fast turnaround time. Pause for applause. That was awesome. Good. Thank you. The completely unasked for. So there's so much we have on our radar that ultimately got cut to time. There's a training I do for internal where I literally says, why isn't blank included? It's because we ran out of time. But the question, it's very much on our radar because like I said, there's a reason why you jumped up and asked it, because it's a very real problem. There are solutions now with the ability to use Kiwi, and then we do want to integrate with that. And just the fact that you were here and my manager's here kind of probably just bumped it up the priority, so we can point to someone who specifically asked for it. Other questions? Wow. Okay, so the question was, is it possible to remove things? Part of the answer is yes, you can remove certain things right now. Systemd, for instance, we covered some, not all of systemd. Let me try that again. We just rip out that kernel thing. It's so in the way, it's beefy. One of the earlier requirements we had was to enable and disable systemd services. Disabling is what made me think of this, is because the reboot manager, there's a few other things that we don't want running by default. You do present an interesting larger question, though, of things like straight up RPMs and packages and stuff. Not yet. I see Reese feverishly scribbling this down for the roadmap, so it is on our radar now. But honestly, that was the first I'd heard about really slimming that down, and I think some combination of this Kiwi integration and being able to generate your own base image, again, using Image Builder, and then pass it through the CLI tool for the customization. I think it's very possible. It's just not currently there today. It's really, am I missing anything, just disabling systemd?
Yeah, you could use the custom script plugin, where if you know what exactly you want to remove, you could just type a zipper remove in a custom script. It will be included. It will be executed during combustion. And it will be get rid of during provisioning. So this is sort of a workaround, but yeah, not perfect, definitely.
Yeah, definitely not perfect, because I see at the end of the day, you're still shipping those bits, and they're still at some point installed. I do want to touch back on this custom scripts, because we mentioned it. It was the last slide in the capabilities. I've used it for really dumb things here, but this is our escape valve for anything that's not actually built in. All of these scripts will run during combustion. So anything that is not currently supported by Image Builder, or any particularly weird situations you're running into, this is a tremendous amount of flexibility you have to trigger something in combustion without you having to jump through the hoops of creating the combustion directory and mounting it and so forth. All of that's handled by Image Builder. We will run these scripts at combustion time pretty much after we run our stuff, but there's ways to circumvent that as well. That gives us this ability for, I mentioned earlier the stack validation talk that's going to be happening. A guy named Eduardo is giving it, and the second we gave him access to this, he's just like using it for stuff we hadn't even imagined, which is awesome, but at the same time, just daily issues coming from this guy. Love him to death, don't get me wrong, but I'm a heckle the crap out of him during his talk. This was this safety valve, where things that we did not directly support, he had the option to come in and write a script for, however complex the script needs to be. And again, it's not 100% of your answer, because it is still embedded in the operating system. But I'm using this as a jumping off point to mention, yes, you could handle that. There's so much more you can do here that can be very specific to your environment, that may not be handled as a first-class EIB citizen, but you still have that flexibility in there. Sorry, very long. I totally hijacked your answer to point out something else good about EAB, but that's what you do when you're up here. You ignore the stuff we don't do, and you talk about, look what we do. So the question was about compatibility lists this is going to run on. There isn't, only because we never really thought to explicitly specify it. In terms of building the image, it has to be an x86 machine that can run a container. But the image that's built is still very much SLE Micro. Build is almost a poor word for it. He pointed out that back in September, Thomas was like, we should call this Edge Image Customizer. And I'm like, yeah, whatever. And now we're customizing images, and I completely regret that. And now in front of all these people, I've conceded he is absolutely right on that. So it is still, at the end of the day, a SLE Micro image that we are customizing the daylights out of, which means anywhere it would have run previously in terms of hardware, virtualization, and so forth, will still run. We're just mucking with the image and doing some cool stuff to it under the covers.
So the compliance with the SLE.
Yes, exactly. And honestly, even if we haven't written that down, I can't see a world in which we would ever ship a product that wasn't fully compatible with SLE Micro. At the end of the day, one company, we're all playing nice together. So we want to use this. SLE Micro is the backbone of what we do over in Edge. And again, you'll hear about that this week. So we certainly wouldn't break any kind of compatibility. I'm sorry, so one other hand pop up real quick. So this was an interesting compromise. The unattended flag is being set under the covers as well. It used to be its own explicit flag. Part of the complication is, I could try to show it to you, but by the time I get to it, this session is going to be over. The first thing it asks you for is, do you want to install? And the second is a modal flag that says, do you want to delete everything on this disk? And that's what we're answering with specifying it there. Can we do it without specifying the disk image? I don't think so right now. Reese, you have, not to put you on the spot, any further input on that? So that basically brings us to time. A couple things. Actually, if you wanted to follow up on that, though, again, the issue's up in GitHub. Feel free to open one up in there as well. If you have any further questions or enhancement requests, it's a very, very new project. We are just now getting it in front of people to ask these sorts of questions that, you know, us as developers, we've got our heads down with a specific view of it. So any of these things we would love to hear about. By all means, contact us through GitHub. Please keep an eye out for the Edge sessions the rest of this week. There's some really cool stuff coming. And thank you all. I appreciate it. Enjoy the conference.
Thank you.